Everyone, thanks for joining in. It's a great honor to be here. Thanks to the organizers who did a great job to put this up as well. My talk will be based on how to architecture a React Native project for scale based on the structure. So here's a little bit details about me. My name is Anayo, Oleru. I'm a software engineer and also an open source advocate. I'm also a mobile web specialist mentor at the Google Africa Developer Scholarship. Here are my stack and specialties and interests as well. You can reach me up, follow me, message me on Twitter, GitHub, and LinkedIn at Anayo Oleru. Yeah. So how important is the architecture of React Native? Architecture is pretty much important for any type of project. So if you're building a medium or large scale enterprise scale applications, the early strategic decisions are absolutely crucial. So what I mean is taking time to plan ahead and invest in scalable architecture will help in the longer run. Bad architecture will lead to complications soon enough. Complications like always refactoring, duplicated code, difficulty in maintenance, the performance of the application, productivity of the developers, and most importantly, the success of the business depends also on the scalable architecture of the project. Yeah, so to illustrate how important this is, I got a graph from Simform that illustrates the difference in growth when you invest in architecture versus when you don't invest in architecture at all. The green linear impression says it all, while the red shows that it will be a big shot at first, but there's definitely going to be a drop in the future, and that will cost a lot for the business. And here's a story I used to describe this situation of architecture really well. Um, I call it the story of uncertainty. So at first, it's a great start, right? Perhaps you didn't give good thoughts about the architecture before laying the first bricks of code, or you did, but it wasn't really the best for the project. You didn't really know about that. You didn't really think about that. So it's quite a simple project, right? So you made it, you deployed it. Now there's a need for version 2. Version 2 needs more components, more devs. So more components were laid. Now components are increasing in number, and that means the code base is growing, it's becoming larger, and things are now getting a little bit complicated. But you felt, okay, it was nothing really to worry about. And now here comes the challenge. Now, let's say there are too many props being passed through multiple hierarchy of components. Or let's say higher level components are being provided with dozens of props and maybe only uses 2 of them, and the rest are being passed to the lower level components. You want a state management tool to help with that. And now you're bringing in probably Redux or Mobix or Apollo or Relay. It's quite important. Now, that's where things get very complicated. So how do you integrate a breaking feature like Redux into a code base that cannot accommodate it? Now, the only way forward will be to tear down the code base and refactor everything again. And that's back to level 1. So this will keep happening and happening for every new breaking feature that will be added if a good thought is not given to the architecture of the project right from the start, or the code base or the architecture is still not scalable enough. That will be waste of time and waste of productivity, both for the business and for the developer as well. So what can help? So sometime I was gathering information from the applications I made using React Native for both bad and good practices. So I felt this is a good opportunity to share that information, and it can help anyone. So there's a principle I use. I call it the principle of scalability, right? So it states that design a loosely coupled as well as highly cohesive component. When it comes to structuring your React Native or trying to create a structure for your application, always keep this principle of scalability in mind. So what it means is each component should be independent. They shouldn't be tied to each other. They should have their own independent responsibilities and should not depend on other components to work, and they should still be reusable. So even if when you make changes to one, no other component should be affected by it. Yeah, so this principle has really helped me a lot in terms of scaling, you know. So let's put this into practice. Let me show you how I implement this principle when I structure my React Native code. So we'll be building a hospital app, and just the practice name, we'll come up with a simple scalable structure at first from the start, with component styles, asset navigation, APIs, and helpers. Each of these feature we'll see how we can bring in this principle of scalability into them, and soon after that we will scale the application. So we'll add other languages, probably French, we'll add state management, and we'll add team to it. And then we'll see how the application will fare, or how scalable it will be, how with this principle of scalability we discussed earlier. So now let's see the code, right? Alright, so I have my React Native boilerplate set up here already. React Native devs are familiar with this. Yeah. Before I almost forgot. We are not building a real project, like a real project with each component per se. I'm not going to be showing you how to create a component or tell you how to build your logic because of time. So I'm just going to show you how it can be structured. So the others are up to the type of project you're working on or what is involved. And I already assume you have React or React Native knowledge already. If not, that will be helpful for you. If not, you can check out the official guide on React Native. And knowledge of Redux will also be an addition, right? Will also help too as well. So, as usual, we'll create a folder that will contain our React Native code. You can call it source or whatever, but for better understanding, we'll just go with the way everyone understands really well. So we'll just go with source. So I'll just create a folder here called source, and now the first thing I do that to help out in maintainability in the longer run is, and to make sure that the tracking of all my paths are intact, what I do is I do a bit of configuration called Aliases, or module resolution. It's aliases or module resolution, path aliases or module resolution. So what it does is like houses all your paths, so it's easy for you to refactor, it's easy for you to read, most especially for nested files or folders, right, or nested folders. I know a lot of people knows about path aliases or module resolution really well, but if you don't know, I won't really go into that. What we just do is a walkthrough. I won't really go into the explanation of this, and it's not really, it's a choice. You can go with it, but I feel it's also part of, if you really want to bring in more maintainability to your structure, your architecture, you can go with it. So you can check it out. I'll put the links on the description, and you could, if you really want to look, if you really don't know about it, you can learn about it from there as well. So let's see. So the first thing we have to do now is our components, right? Start with components. How do we structure our components? So this is one of the most important aspects of React or React Native. There's an interesting question raised from an article I read some time ago. It says, do you know you can actually write an entire application code in just one component? I was like, yeah, of course it's possible. I've never thought of that before, but that would be the worst thing anyone can ever do, right? So what's the better way to structure a React Native component? So there's a system design I really find helpful. I know most developers really know about it as well. It's called atomic design. So normally what developers do before is they have a folder for all kinds of components, right? A folder called component for all kinds of components. And then in the longer run, you start having a surge in the number of components you have. So when you start having like 30, 40 or higher more components, because now, because you can't easily find components, developers might start creating components that already exist. But atomic design comes to the rescue. Sorry. So atomic design is made up of atoms, molecules, and organisms, and there are more, but I just had to cut mine there. Yeah. So for React, you can use mixes of pages or templates. But now let's see how this works. Atoms are the smallest possible component, such as buttons, such as titles, such as text, while the composition of two or more atoms makes up molecules. So now the composition of two or more molecules makes up organisms. Now the composition of two or more organisms makes up screen. You see how that works, right? Now let's see. With this design, it brings up that principle of scalability. It gives each of your components the independence, and they can also work together as well. They have their own responsibility, and they can bring that responsibility together and work together. Now, here's an image of an app to you. I just did quite some little bit of skill, little bit of drawings to explain this atomic design more properly. So the red lines are atoms, the blue lines are molecules, while the green lines are organisms, right? So as we can see, the red lines has circle around the text, the title of the book, the image of the book, the loader of the book. Those are atoms, right? Now they work independently, but now they are working together as a molecule. Now all of them together are molecules. Now all molecules on that screen are working together as organisms. So now all the organisms on that screen they are on that screen really well. So they are now the composition of organisms now makes up the whole screen that is rendered to us now. So this actually really I find really helpful and very, very helpful. So let's see how that works really well. So let's jump back to our code, and then let's see how I create a structure around this. So what I do is I create a component folder, components, and I also create a screen folder, right? So in my component folder, I create a folder called atoms, and I also create a folder called molecules, and I also create a folder called organisms. So I'm doing it this way for proper clarity. Yeah. So in each atoms, I put up like a door to all the atoms. So that's an entry file, index.js in each of them. So for all my atoms, all my molecules, organisms will all be passed. You can all access them through the index.js file. We know about this already, so no. Right. So this is how I structure it. Now let's take for instance title. One of the atoms here is title, one of them is loader, right? So let's have a file called title, title.atoms.js, and what I have here is I could have loader.atoms.js, right? So the component for loader will be here, the component for title will also be here, and I'll pass them through index.js, right? Now, coming back to molecules, from our screen, we can see that the book view is a combination of the loader and the title as well as other components inside, as well as other atoms inside. Now, let's create a molecule. So I'll create a book view, which is the blue line. I'll call this book view .molecule.js. So my atoms all will be brought together to work together in this molecule. And now from the organism, you can see the green line. They're all, let's say, the book container. So we could call this book container dot organism dot js. So I'm bringing in probably book view, and other probably we could actually have a organism called collection view, popular view, and probably the sidebar view, and the rest. And now we could bring them right into our organisms, right? They will be each file on our organism folder. And then we want to create this screen, this particular screen now. So let's say this is the home screen, right? So we can have the folder called home screen. So what I do is, in home screen, I create an index.js file. Index.js file. Okay, that's not. So here we have our home screen, and we can have all organisms needed for the home screen to work in our index.js file. Easy. So for that sake, we'll need our login to explain something better. So let's create that login now. Login screen.js and index.js inside of it. So that's really how I structure my component. So with this feature, I could easily add screens. I could easily add components, and I can easily find components as well. So knowing the structure really makes it more maintainable and more scalable as well. You get that point, right? So that's it for components. Now let's see what's next. How we can structure our styles, right? So how can we structure our styles? So what I do is I put my styles in each component they are responsible for, in each component, not in a different file, but in each component. So for easy view, so I could easily style them easily without even going from one file to another file, right? So it's time. Yeah, that works with time. So it's also cool as well. Other people could actually have a different style file for their styles, but I put my style in each component they are responsible for. So, but style objects are different keys involved, right? There's fonts, there's the colors, there's images, there's logos, there's responsiveness. These are properties that really are necessary to work with style. So how do I structure each of them? So for these features that are important, or what I do is I make sure they are not static on each style component, on each style object, on each component. You get what I mean? So they are not static on each style object on each component. So let's see how that works, right? So what I do now is, we close this up. I'm going to create a folder called styles, and each of them will create these features. So I know most of us do this already, but let's see how different it might be. Okay. So colors, what am I doing? Get out. My typing really. So let's see. So colors, images, logos and responsiveness. Logos. So responsiveness will come up later. We'll explain that further. So this is how I structure my styles. For each color, I pass in the necessary color. What is necessary? Colors have its own properties as well. So For instance, no. So what I do is I create a file called main color.js. So in main color.js, this is where all my colors, both background color, let's pluralize this. So all my colors, both background colors, both button colors, every single color will all be in this file. They won't be static on each style folder. They will all be in this file. They will all be coming from this file. We'll see the importance of that later. So, not to forget, we want to also place our index.js file. So what I do here mostly is create a logic to display these main colors, right? So probably if there's a probably the default color should be this main color in case there's any other colors coming up. So you can easily swap or switch to those colors instead of the main colors. We'll see how that when we are scaling the app, we'll see how that plays out. So let's just wait up to when we start scaling the app. Then for the font, what I do is I create the sections for fonts. So there are several sections for fonts. Font family.js. There is font size.js. There is also font, let's say, font style.js. Is it font style? Font weight. Yeah, 71. There is we also have line height as well. JS. So you can actually independently separate each property of fonts, so that they are independent, to bring up that independent principle scalability into it, right? So this is how I scale it, and not to forget again our door file, yeah. So index.js file to access everything directly from this. Now, the next is images. So as we all know, images will all fill this file. Or the only thing I'm going to do here is passing my index.js. So in index.js, what we'll be doing is just bringing up all images right in this file, right? So you can also make sure your images are optimized as well for better performance. You can use Cloudinary. They have great optimizing tip as well. Great optimizing features, yeah. So why I do this is, as we all know, okay, to explain why I do this, let's also move up to logos. Logos is almost the same as images, but they have different purpose. So I'm also going to create an index.js file as well here. So with this, if there's a need to change a particular image being used, instead of going through all components to change the image, all I'm going to do is change the image from here, change the value of the image or the key of the image from here, and it will reflect everywhere, right? So that's also with colors as well. So probably you have like 30,000 components, like Facebook that has 30,000 components, and then you want to change the colors or the theme of the. Okay, we'll get back to that. We'll get onto that though. So let's just move up with this. Then the last is responsiveness. The last thing, there are many other things, but let's see how we add responsiveness. So for responsiveness, I call mine screen calculator. So screen calculator, screen calculator. Yeah. So in screen calculator, I could create other files that to help bring responsiveness for every single features of my app, like mixins, the JS. I create file for spacing the JS. and many other ones to actually bring up responsiveness. So with this, you can import them into fonts and make your fonts also responsive as well. So this is how I structure my styles. Yeah, easy and independent. So no one depends on each other. They are independent, right? Now the next, how do we structure our assets, right? Our assets comprise of icons and icon. There's something called application book. Yeah, we'll get to that. But yeah, why did I separate assets from styles, right? So in order to avoid deep folder or file nesting at all costs, I separated it from styles. Yeah. And the thing is, I don't regard icon as a style because it won't be used in the style object. If it will, then it should be in the image folder. So styles like XVG, PNG, JPEG, or JPG. So let's do that. Let's create our assets, right? Our assets folder, we'll create it in our source tool, source, and right there we'll create our icons. Icons, and I call this application book. So still the same, we create an index.js file to pass all our icons through. Then what the application book is all about is, this is another very important area that has really been helpful in terms of scalability. So every single static text using the application will all be coming from this file. I mean, every single static, 100% every single static text. So no component will contain its own text. All text will be coming from application book. So what we are going to do now is I'll create a file. So since we are using English at first, so I'll create a file called English en.js. So this is where will be our object that will contain all text, static text using our application. And the same thing we'll pass in our index.js. We can also do some logic here to default to English.js. But if it's not English.js, then you default to whatever thing or whatever language you want to. So that's it for assets. So as I said, one reason why I separated assets from styles is to avoid deep nesting at all costs. So one thing I do is 4 layers. I make sure it doesn't go past 4 layers, right? So I make sure from source, assets, application book, it doesn't go past this. So it's either 1, 2, 3, 4. I could add any other folder. It shouldn't go past 4 layers at all. If you go past 4 layers, I try as best to keep it to 4 layer or 3 layer or 2 layers to avoid very deep nesting. For maintainability issue, we want to try as much as possible to do that as well. Yeah. So what next? Our navigator. How do we structure our navigator, right? This is one pretty much straightforward, because you can use any navigator library or package of your choice, and then React Native have this standard of navigator. You have tab navigator, you have stack navigator, you have door navigator, and the rest. And now what I do is I create also a folder called navigator, and then I single out each navigator to his own file or his own folder. Right? So first I create a root navigator where all our navigator will come into, right? So I could create stack navigator. If our application will be using a stack navigator, I'll put in stack navigator. If the application is using a bottom navigator or a tab navigator, well, I'll put them there. Then the root navigator, we house all the navigators and probably do our logic for us, our authentication logic as well. So that's really up for Navigator. Then API, yeah. So this is another important side. How do we structure our API? So for me, I create a folder called service. And service will contain all. No, that shouldn't be there. It should be so our service will contain like any other thing that has to do anything that has to do with APIs, right? So you can create any name of your choice. I do call mine HTTPS service.js, and then what I do next is same thing, index.js. Sometimes this might not be necessary here, but you could also do it for maintainability sake, for scalability sake. So you can add any other file that has to do with APIs. You can all add them in your services. I'll just rename this to be services. So the next is services. So everything that has to do with HTTP service, you configure any HTTP clients you are working with, you can all have them here. So our helpers. So what helpers does now is everything that has to do with other functions. If we have any other functions in our app that we want to use, private functions like maybe currency, special currency formatter, local storage, the mobile local storage functions as well will all go into helpers. So what I do is I also create a folder for you called helpers. Oh boy, what is wrong today? I create a folder called helpers. So in the helpers, I could have a local storage.js where I have all functions for local storage. We all go into that file, and then of course, as usual, I have my M3 file in there. So that's it for helpers. Then, so this more like it. With this, you have your files, you have your components independent. They are independent. They have their own responsibility. They don't depend on other files or other functions or other components to work, right? They don't really depend on that. But when you bring them together with those functions or with those components, they easily work together. They easily coexist together. So next is now let's scale this project and see how accommodating it will be for any breaking feature we want to add. So one of the breaking feature is new language we want to add to this project. So how will the project fare? Let's say our patients and our doctors are mostly French-speaking natives now. Now they want to be able to change the static text of the app to French and back to English whenever they want. So let's scale and add French. So to do this, all we have to do is text, right? So it all has to do with text now. So that's where scalability, the importance of independence comes in. So in our assets, we have application book, and we have English here, and we have some logic here that defaults to English. That means we can actually change. When there's something, it won't like default to English though. So we want to create a file. Probably we'll create a file called fr.js, whatever how it's called. We can call it French full, and then we can pass in our the static text translated to French, from English to French, and then do our logic for how it should be rendered, depending on when they switch to English or when they switch to French. We use mobile loader storage as well. So with this, boom, we've actually scaled the app with a new language, right? Easy. Nothing was broken in the process, and straightforward, right? And it's easy. It's quite understandable here. So even though you have thousands of atoms or thousands of molecules or thousands of organisms or thousands of screen, you still, let's put this as screen, you still can easily understand what, or easily add that feature without breaking anything. So now, what's the next or next breaking feature we want to add to scale this project? That's state management. So we want to bring in Redux. For instance, we want to use Redux here. So one thing about Redux is it's something you don't mess with in a large-scale application, else it will be a big mess. So what I do for Redux is I create a folder in my source called store. So here is where my store configuration will be. Store configuration or store config.js, right? Call the store config.js, and then next is my reducer. So my store configuration will go in there. Then for reducers, what I do is I also create a folder called reducers, and then I have the root reducer.js where I'll combine all my reducers. Then in each reducer will contain, this reducer folder will contain folders for each reducer. So each reducer is also independent on its own folder, but they'll all be combined in our root reducer file. So let's take for instance, okay, we'll get to that though. But then, how about our action types, right? So what I do is for each screen will have its own action and action types. Yeah. So let's see how that works now. In our screen, we have login screen, right? So in our login screen, what I do is I create a file and I call it so I create a file and I call it action.js or action. Yeah, just keep it as that. You could have a convention for the file name in here. It could be action.login.js. And I also put in my action types. Action types.js. And so my action for login screen, actions for action types, actions for login screen, actions for login, and action types for login will all be in login screen. They are all independent of themselves and only independent to work with what they are supposed to work with, like the particular action they are supposed to do. On the particular screen they are supposed to do that action. So they all go into the login screen. If it's registration, it all goes into registration screen as well. There's something else I do. Sometimes it depends. So for separation, for independence still, I separate map states to props and match dispatch state to props as well. Match state to props, you could do that too as well. This is quite long, and I could say map dispatch state to props. Let me just call this long. Oops. So you can rename this as your convention you follow, but this is what I do sometimes. I make sure I differentiate the two files and map state to props, map the dispatch state to props in its own file. So they are all independent. They are not in index.js. They are not in the logging component. So logging component as its own, it's a component. And then there are actions, there are action types that map the state to the props, maps a dispatch state to props as well in their own file. But now they all still work together. So with this, it's quite scalable. You can pull any of these functions out without really messing around with the component or without breaking something. Right? You can pull it easily. You can read each. You can read the component easily, and you can read what this component is actually doing, and where you can easily find what you can find things easily. You can maintain it easily. That's what scalability. That's how to bring up. That's like a guide to bring up a better architecture, right? Now, this is like it. Then back to our reducer. So what I do? We have a login. We have login screen. So I just create a folder called login reducer, and in it we have my login reducer. I could also call that index.js, right? It's my login reducer. So whatever else I want to do, they all go independent on its own reducer. So I'm bringing all reducers into root reducer and combining them as I said before. So this is straightforward, isn't it? So this is how easily accommodating the code base, the architecture was able to bring in Redux into it without really like touching everything or breaking anything, because the architecture was accommodating, it was flexible. So that's it for Redux. Now let's add a theme. Let's add a theme. This time, how do we add a theme, right? Theme of the screen. So here we go. Let's say our night shift patients and doctors want to be able to change the theme of their screen. So that will definitely be on our colors, right? Our background colors, our text colors. They are all where we all place them in our styles and colors. You see where how important independence comes in here. So for us to add this new color, all we just have to do now is bring in, probably you could say dark theme .js, or we could say light theme .js, or just for them sake, we could say just for dark color, dark colors .js and light colors .js for convention's sake. It's also part of a great architecture. So now we can bring all the colors we want to our patients and doctors to change, to view when they change to dark colors or when they change to light colors. And we can't do all the logic to view, to render any of these colors in our index.js. And boom, we've added theme. Quite easy, right? So for Fastlane, we're not really gonna like go into Fastlane now, but it's also quite easy. With this structure, you can easily add Fastlane architecture or Fastlane breaking change here without really touching or without really trying to refactor everything again. It will all work here. So that's actually it. That's how that principle of scalability could actually work. Could actually bring up independence on each component, on each function, and with it you can easily, in the future you can easily bring in anything, and you don't have to refactor anything because each independent are on their own. Each components are on their own, and so nothing is connected together. So nothing, you don't have to break anything to slash out, right? So that's how important the principle of scalability can help, and it's really been helpful to me as well. So although this is not a stone structure, every project has its own format, has what is involved. This is just a guide to help. I have a repository on GitHub to show you what I've done right here, but I'll soon be moving into Quixy. Quixy is a CLI that helps developers kickstart projects easily online and even offline, just from the comfort of their command line, right? I'll put the links in the description section, the GitHub, and link to Quixy. You could check Quixy out. You can also follow or reach out. Also, if you need help with any of this as well. So, in summary, what we've discussed and tips that I didn't mention are follow the principle of loosely coupled code or components and prepare for the foreseeable future. Yeah, whatever you do, how you structure your code, think about what will happen. Will there be need for bringing anything again in this particular scenario or in this particular architecture or in this particular section in the future? If there is, what would happen? Then there'd be a need for a factor, yeah? So if there's a need, then try to fix it up quickly there so that it will be easy to bring in anything when it comes. Strictly follow a file naming convention and component as well. Avoid too many nested files and folders. That is one very important part. Too many nested files, avoid it at all costs. If there is, then you can use Aliases and model resolution to help you. But avoid it at all costs. It's quite headache for developers to maintain a code base that has like 5 or more layers of nested files and folders. You also document your architecture as well. Use packages or libraries to help you handle side effects. Like for Redux, for instance, Redux has Redux Sega, Redux Tongue. They could help you with side effects your application. Sometimes what I also do is I create private packages if there's a need for something to come in that won't really be real, like something to come in and into the code base to be used for some certain amount of time. All I do is create a private package and just install it to the application. As soon as it's over, just pull it out, right? So we can also do that as well. So that's all. Thank you. It's been a great ride so far. If you got questions, reach out to me on Twitter, on GitHub. You can reach out to me on LinkedIn as well as at Anayo Oleru.